right, you guys ready? All right, class.
Yes.
All right, thank you. Okay, so we're going to go through here, and we're continuing the 5.4 and going with interpret integrals involving rectilinear motion. So, that's velocity. Okay, now, velocity is not the same as speed. So, for an object in rectilinear motion, moving with velocity v, the net displacement, or signed distance of an object whose motion begins at A and ends at B is given by, right here. I have the integral of that from A to B over the bound. So starting at A, ending at B. And it is the displacement, so how far it's gone, so total distance, traveled by the object from T to here is given by here, total distance. So, let's say Denny is driving to school, okay? His velocity is probably like 80 miles an hour through that school zone, right? Okay. So, but Denny wants to make sure as he's growing through that school zone, he hits this weird, noisy pothole, okay? But then to make sure everything's okay, he backs up over it again. And then he goes forward again. So, what we're going to look at is total distance traveled, even though that he backed up, that's also distance traveled, right? And then he went forward again. So, if you think about it, he went through the school zone, back through it, over the noisy speed bumps, and then back again over it one more time to make sure, that speed bump is no longer noisy, right? Okay, so that's what that means. So we have right here, if velocity of t is greater than 0 for the interval from A to B, then the net displacement and the total displacement traveled are equal. So during that time, if Denny backs up at all, then it's not going to be the same. Total distance is not going to be the same as my net displacement, my distance traveled, because he did go backwards. Okay, it's kind of like walking from here to Douche Bros. Okay, if I walk forward, it's one value. But what if I walk backwards? That would be walking backwards. Would that be like a negative velocity?
No, that. Wait. Yeah.
I'm walking backwards, right? That would be a negative velocity there. But I'm still distance traveled, and that's where we get the absolute value for that one there. So walking forward or backwards, it doesn't matter. That's why we have the absolute value of my velocity traveled. Because just because I walk backwards doesn't mean that, I'm going anti-distance. I'm still traveling a distance. An object in rectilinear motion is moving along a horizontal line with velocity. Here's my velocity. Okay, 3t squared minus 18t plus 15 in meters per minute for time from 0 to 6 minutes. Find the net displacement of the object from 0 to 6. So that means how far have traveled. So think about that. If I walk from here to Douche Bros and back, what is my net displacement? Say 0. Because I'm still right here, right? So my net displacement that I've changed from my trip is 0. Even though I went all the way there and all the way back, my net displacement is 0. So my displacement from where I started at is 0. Because I'm back at my point of being 0. Now, I'm going to walk over towards the 400 restroom over here. Okay, that's further away than Douche Bros, right? So it's the opposite direction of Douche Bros. So my displacement is going to be negative, isn't it? Because if I start here, I walk to Douche Bros, I walk backwards all the way back, but I end up at the bathroom because, I went and got some super strong coffee that's going to give me the runs. So I'm at the restroom over there. So my net displacement, I am further back away from Deuce Bros than what I started. So that would give me a negative value there. But my net displacement is only determined from where I started at. So I would have a negative as I end up in those restrooms there. So I'm further away than what I started. So for this one right here, the net displacement of the object from 0 to 6. So let's go ahead and do my integral. And I had my, oh, there it is. So my pen. So it's integral from 0 to 6 and 3t squared minus 18t plus 15 dt. Did you write all that down? Or are you just sitting there, staring at me awkwardly? Yeah, okay. All right, let's integrate this. Denny, you ready? What are we going to get? What else? Over 3. And what's going to happen to those 3's? They're going to cancel out. Okay, next one. Mary Cruz? Over 2, very good. All right, plus Lindsay, you ready? What are you going to get?
15.
Just t. T, and that would be to the first, right? Now, I would divide by 1, but I don't need to write that, right? Okay, good. And my bounds are from 0 to 6. All right, so also that 18 over 2 is going to give me 9. So I'm going to have t cubed minus 9t squared plus 15t. Oh, it should be minus. Plus 15t from 0 to 6. So let's start by plugging those in. So t to the third, so 6 to the third power. Did we do that one yesterday also? So what's that? That's like 36 times 6 is, what is it? 216, thank you. 216 minus 36 times 9? 36 times 9.
324.
324? Plus 15 times 6? 90. And so minus my lower bound. I don't have any constants here. If I had a constant, then that would be, I would actually just plug it in, but I don't have any constants. So if I plug in 0 all the way across, all this right here is going to end up becoming, say 0. Yeah, because plug in 0 there, plug in 0 there, plug in 0 there, so it's all minus 0. All right, and right here, what do we end up with? Negative 18? Okay, so it's negative 18. Now let's go back to what that said. So from right here, net displacement is just given by this. Net displacement. So what does that mean if I have negative 18? What do you think it means? Yeah, I went back more, right? So I'm further away than when I started. So instead of going forward, so if I think of this as a number line, everything going from starting here, okay, 0, and let's go 100. And then over here, and let's go -50, just because. So my displacement here says that I started right here. I went forward. How much? So I went forward a certain amount. So I went forward and I turned around. I went further back and then I turned back around and I ended right about here at -18. So this is Denny driving through that school zone, okay? So he went forward through the school zone at first, backed up through that noisy speed bump, and then came back over here. Does that make sense? So we're further away than where we started. Okay, so there is my net displacement. Okay, finding the total distance traveled. Now for this one right here, I gotta try and break it up though. Okay, because I gotta find where the points that Denny turned around and drove backwards. So that's what I have to go through. So let's break this up. So I'm gonna break it up into parts. Right here. So my parts are going to look like this. So it's going to be the integral from 0 to something. I got to figure out where those points are. So let's take my values, which is 3t squared, was it minus 19? Minus 18t plus 15. Now we're going to take my function. Okay, this function is my velocity. That's my velocity. Now, if you guys remember back when we did derivatives, right? There's something special about velocity. Okay? If velocity is positive, I'm going forward, right? Say yes. If velocity is positive, I'm going forward. But if the velocity is negative, I'm going backwards, right? Yes?
You go sideways.
Okay, going backwards and then, okay, forward. So we gotta see where that this function of velocity is going to change from positive to negative. So what would I do to try and find where these things is going to change from a positive to a negative? Make it equal 0. Very good. So let's make it equal 0. So by doing this, I'm going to find those locations. So it's going to be 0 equals, now, some algebra right here. I'm going to make this a little bit easier. So I'm going to factor out a 3 to make life easier. So if I factor out a 3, I'm left with t squared minus 6t plus 5. All right, t squared minus 6t plus 5. You guys should, at this, factor that out. I should be able to factor that. What two numbers multiply to be positive 5 but add together to be negative 6? 1 and 5. That's going to be it, right? Because is it negative and positive or what? So to get the, so I'm going to have a t here, I'm going to have t here, and you're saying 1 and 5. What are the signs on those?
Addition.
Negative, negative? Yes, they do. Two negatives will make this positive right here, right? But when I combine those two together, that's going to give me the negative, right?
Oh.
Yeah? Okay. I know it's been a while since I did some of these, so that's why I don't mind going back over it. And how do I verify that this is actually the correct thing? Could I FOIL it and actually check it again? So if I FOIL it, I get t minus 1, t minus 5. Let's go ahead and do my math. So t squared minus 5t minus 1t plus 5. Yep, there it is right there. Yeah? Okay. So yes, so that is working. So I just verified that I had that correct. And now let's go through. So now I have places that it's going to be equal to 0. So what is my t values going to be? T is going to equal what here? Positive 1, right? Positive 1, because I set each one of those values equal to 0. And t is equal to 1 because, so for that to work out, I would just add 1 to both sides, t equals 1. What about for this other one? T equals positive 5. So on my timeline, I change directions at 1, and I change directions at 5. So let's go back up here. No, I don't want to do that. There you go. Okay. So let's change this piece right here. So now I am going from 0 to 1, right? 0 to 1. And that is for my function, which is the v of t, dt, plus my next one, which is going to be from 1 to what? 5, very good. 1 to 5. My v of t dt plus my last one, which is going to be my 5 to 6 v of t dt.
Good morning, Bobcats. This is Danielle Schills, your assistant principal for student support. Please pardon the interruption. I just wanted to remind teachers and students that today we are starting our e-hall pass. So please make sure that if you are leaving the classroom, that you have already gotten the teacher's approval and your passes have been entered into the system. If not, you will be sent back to class in order to get your pass approved. Once again, we are starting e-hall pass today. Nobody should be outside of class without an e-hall pass ticket. Thank you. Have a great day, Bobcats.
Okay, so let's plug it in. So if I do from 0 to 1, that's going to give me what value? So I could back up where I already did my derivative. I get my derivative here. So if I plug in 1, that's going to be 1 minus 9, which is going to give me negative 8, plus 15, which is positive what? 7? Maybe? Did I say too many words? I'm getting kind of worried because I think I might have said too many words.
Yes.
Okay, so let's actually do the derivative. So the derivative of that one would be, what do we say? So t cubed minus 9t t squared plus 15t. And from my bounds, so if I do my bounds, my first bounds is going to be from 0 to 1. So plug in 1. 1 minus 9 plus 15.
Wait. Oh, you did integral.
Yes, that's it. And I just plugged it in my bounds. My upper bound is going to be,
Because you said derivative, and I thought you were leaving the exponent right.
did I?
Yeah.
I'm sorry.
Why?
I'm sorry.
Okay.
So we get what, 7?
Yeah, positive stuff.
Okay, so it's going to be positive 7 minus my lower bound, which is just going to be 0. There we go. So right here, this value is going to give me 7. Now let's do the other one. So that's going to be my T3 minus 9t squared plus 15t from my bounds of 1 to 5. So the upper bound is going to be, what's that, 125 minus 25 times 9 is going to be 170, oh wait, no, 225 plus 15 times 5 is 75. And so what is my displacement on this one?
What do you mean displacement?
Do the math.
Yeah. Negative 32.
Negative 32?
Wait. Yeah.
My math might be wrong, so, you know.
Wait, so 1 to 5, bounds 1 to 5.
So right here, this should be, I'm just checking this math right here.
Yeah, okay.
So this one right here should be what, 25? Negative,
Yeah, negative 25.
okay, so negative 25 minus the lower bound. My lower bound is going to be 7,
Yeah.
right? So that's going to give me a total of negative 32. But since we're talking about displacement, this one right here is supposed to be an absolute value. So this one's going to be 32 here. This is where Denny put his car in reverse and backed up over those noisy speed bumps. Yes? Because it's still a distance traveled. You're just going in the other direction. All right, next one here. So my last one right here, so it's going to be t cubed minus 9t squared plus 15t from 5 to 6. My upper bound from 6, what do you say that's, 216? 6 to the third, 216. Minus 9 times 36 was negative 324. And plus 15 times 6, which we said that was 90. There you go. And put all that together, we get, is that negative 18? Yes? Okay, so we get negative 18 minus my lower bound at 5. My lower bound at 5 came out to be negative 25. Yes? Good. because that's what we did up here. So negative 25, negative, negative makes that a positive. So in between those two right there, we're going to get 7. So this is going to be 7. So my total traveled, my total distance, since we went forward 7, backwards 32, and then forward again 7, what's that going to be? 39, 46. And I believe these are, what are my units on this one?
Meters per minute.
Meters per minute. So my distance traveled is going to be in meters.
The meter.
All right, questions or complications or anything? Does this seem easy enough, or you guys understand why I broke it up into 3 different parts?
Yeah.
Okay, because my middle section had a negative portion where we turned around and went backwards. And that's why I had to actually go through and do all the different parts.
I remember figuring this on the homework. I just didn't know why. One of them was absolute, and now I know.
Yeah. So, from there. Any other questions over any of this? No? Danny, you good? All right, I think we are done for today. Are we? Is that the last set of notes?
Yeah, I need to go back on YouTube and check.
Yep. All right, so make sure you guys all like, share, and subscribe. Hit that notification button, support my channel, buy stuff from my merch store.